Okay, let's debrief the portion of the class about thinking about math as a language. So I said consider a series and its partial sums. So as soon as you read that, you want a particular picture popping into your mind. Just like if I said consider a linear function, you might have something like this pop into your mind. Or if I said consider a geometric series, you might have something like that pop into your head. So here I have a summation of a whole bunch of terms. So what's in your mind is this. You're thinking, okay, I've got several terms being added up, but they go all the way out to infinity. And then I'm also saying consider the partial sums. And remember, S subscript n refers to the sum of some number of terms. So the third partial sum is the first three terms added up. Let's see how to notate this. This would be the nth partial sum, is the sum of the first n terms. Okay, so we've got this in our minds. So if we know that limit as n approaches infinity of a sub n is 3, what do we know about the series? So first of all, what am I asking about? The series. And the series is asking about the sum as a whole. So I want to know what's going on with the entire sum. Okay, so what does it mean if the limit as n approaches infinity of each term equals 3? All this part is saying is that the individual terms are getting closer to 3 when the term numbers go towards infinity. So again, you want to imagine in your mind, what would a series look like that fits this description? Here's what happens in my mind. So what's going on here is a sub n can describe any generic term. So we're saying imagine a generic term, but we're imagining it as the term number gets larger and larger. So we're saying what happens as our term gets larger and larger? We're saying the limit of that process as the terms get larger is that the individual terms get closer and closer to 3, and that's what's happening here. So I've got terms that don't look that much like 3, but you see that as I continue, they're getting closer and closer to 3. Okay, so now that we're imagining this, what do we know about the series? What do we see about the sum? And you have to have in your mind, what have we been talking about recently? So recently we've been talking about there's only a couple of things that can happen with an infinite series. Either it can converge, which means it's getting closer towards a value, or it can diverge, which means that it's not approaching a value. So here I'm imagining what happens if I add an infinite number of things, but once you go far enough in the series, all the things are extremely close to 3. That's almost like saying let's add an infinite number of 3s. And clearly if I'm adding an infinite number of 3s, what's happening is the entire series is diverging because it's going towards infinity. So that's the exercise here. You have to read a statement, imagine what is it telling me about a series, and you have to be able to imagine a series that fits that description. And then once you're imagining it, the next part should be pretty easy, because you should just look at the thing in front of you and say, well, what is this thing obviously telling me? So let's try a couple more. Okay, so this one's almost the same as last time. I've still got limit n approaches infinity, but this time, instead of a sub n, I've got s sub n. And remember, s sub n is the nth partial sum. So here I'm saying, okay, what happens as I have the sum of the first n terms, but n is getting larger and larger? So I'm imagining sums of more and more and more terms. And this is saying, as I take the sum of more and more and more terms, those sums are getting closer and closer to 3. So here's what's happening in my mind. I think, okay, if I have the sum of the first 4 things, maybe that's 2.5. And then if I have the sum of 5 things, maybe that's 2.9. And the sum of 6 things, maybe that's 2.99. So I've got the situation where adding more and more and more terms is making me get closer and closer and closer to 3, because that's what this is actually describing. So what do I know about the series? What I know is that it converges to 3, because this is the way that we defined convergence. We said that a series converges if its partial sums get closer and closer to a value. So we know that whatever the infinite series looks like, it converges to 3. Okay, this one says that the 10th partial sum is 2, and this summation equals 3. What conclusions can we draw? So let's imagine it. So So the 10th partial sum being equal to 2 is just saying that the first 10 things added up are 2. What's this thing saying? Well, I've got a sigma, so I've got a summation. And the summation starts with n equals 11 and goes up to infinity. So that summation is, describing what happens if you add up the terms starting at 11, going all the way up to infinity. And it says all of those added up equal 3. So what do we know about the entire series? These add up to 2, the rest of them add up to 3. So the whole series must converge to 5. And again, the conclusion is very easy if you're able to imagine what is this language telling you. Because math is just a language that's describing something that you can understand. Okay, last one. So we've got that a summation of terms up to infinity equals 10. And we want to know what can we conclude about this and what can we conclude about that. So let's imagine. This is just saying we're adding up a bunch of terms starting at 1 going to infinity. So that statement seems to be saying we have a series that converges to 10. Okay, let's start on this side. What can we conclude about the limit of the partial sums? Well, remember, the partial sums are describing what happens as you add more and more terms. So I don't know the values of the partial sums, but I do know that as I add more and more terms, the partial sums must be getting closer and closer to 10, because that's what it means for the series to converge. So this statement and this statement are saying the same thing, just with different language. Here I'm saying add up an infinite number of terms, you get 10. Here I'm saying the partial sums get closer and closer to 10 when you add more terms. Okay, what about this? So this is asking what happens to the individual terms as I go further along in the series. Okay, well, this one we have to have worked a little bit with the series. You have to kind of remember some of the things that we did in class when we were working with series. We can't have any series converge unless the terms themselves are getting smaller towards 0. And getting smaller towards 0 doesn't mean it always converges. But, in our first example where we had a whole bunch of terms that were all equal to 3, that goes to infinity. If we had a whole bunch of terms that were all very, very close to 1/100th, that would also converge to infinity, because even though I'm adding very small things, they're still not going to 0. And so if I add, 100 billion, trillion, quadrillion of these small numbers, that's still going to go towards infinity. So in order to converge like this, we know that the individual terms themselves have to approach 0. That's it. I'm going to try and make up more questions like this because you see this language very, very often in more advanced math courses. And I feel like this is a very fundamental thinking skill, to be able to read a general description and use that to generate some picture in your mind that you can use to understand and draw conclusions about the object that's being described. And when I say object that's being described, it could be a function, it could be a series, whatever it is that we're trying to understand. We refer to that as a mathematical object. Okay, I hope that this was helpful.